Hello, my name is Ufuk Topcu, and I am on the faculty at the University of Texas at Austin, where I run the Autonomous Systems group, and our work focuses on theoretical and algorithmic aspects of design and verification of autonomous systems. In particular, we address challenges in autonomy due to the following factors that I list in the slide. For example, that they need to operate in dynamic environments, deliver complex missions, often rely on heterogeneous and complex system architectures. They need to survive runtime faults and need to be able to operate in a priori unknown environments, adapt to various user characteristics, rely on imperfect perception, and also at runtime against adversaries, they need to protect the integrity of their mission and safety critical information. And I put verifiability at the center of this picture because we try to do all these things while keeping the resulting autonomous capabilities verifiable. And how do we address these challenges? Our perspective is that autonomous systems are nobody's comfort zone. There's no single field that can address all these challenges, and therefore we need hybrid solutions. And oftentimes the research that we do in my group fall in the intersection of learning formal methods and control theory. We have a range of projects, and I would like to highlight one of these projects, which is a NSF Cyber-Physical Systems Program Frontiers project with the title of Cognitive Autonomy for Human Cyber-Physical Systems, Turning Novices into Experts, where we look into how we can develop autonomous systems that will be receptive to receptive to the capabilities of the human users, and at the same time pull these capabilities up. And the type of problems that we tackle are how we can compute cognitive models to characterize humans' capabilities and the interactions with autonomous systems, how we can integrate these models into cognitive control, how we can then monitor the interaction between the human and the autonomous systems at runtime and interfere if necessary and only if necessary, and obviously close the loop and be able to provide feedback to humans on the capabilities of the autonomous system or the potential failure modes. This is a large collaboration led by Miko Oishi from University of New Mexico, and the other participating institutions are University of Texas and University of Colorado Boulder and Purdue University, with several collaborators from national labs and government labs and industry. And we are also tasked with answering this one question: why am I interested in collaborating internationally? The answer is relatively straightforward for me, because in that way I can have access to complementing capabilities, perspectives, and resources in research and education. And I emphasize it as both research and education. I have been lucky enough to have a good number of very enjoyable international collaborations. I list only a few of these things here, but also I have been in situations where where I felt that these collaborations would have been more sustainable if there was institutional structures. NSF plays the role of facilitating interdisciplinary collaborations within the United States, and I'm sure in Taiwan there are similar structures, but we need more systematic interactions between these two countries and between the United States and other countries, I believe. Thank you. This is all.